I will give you one example of how you can apply this crisscross system when you are giving such competitive exams. Remember, in many of these exams, you have one question given to you and 4 alternatives. That means 4 answers are already given, out of which you have to take one answer as the correct answer. In such cases where you have 4 options already given to you, the systems of Vedic math can be of immense help. Let me give you an example. Suppose I am giving any such competitive exam and there is a question in my paper which says, say for example, I have to multiply 358 by 121. Now I know they don't ask us simple questions, but we are just taking one hypothetical situation. And against these questions, I have been given 4 options, out of which I have to select one as the correct answer. Let us say my 4 options are 43328, 43398, 43318, and D 43316. Out of these 4 choices, I must take any one as the correct answer. So let us see how we can do it. I write my question here, 358 times 121, and I apply my Vedic math system. First step says multiply these 2 numbers, so I have 8 times 1 is 8. Now, the moment I have 8 over here, I look for all the alternatives that end with 8. Here, option A ends with an 8, so it is a possibility. I come to option B. Option B also ends with 8, it is a possibility. I come to option C, it ends with 8, so it is a possibility. And option D ends with a 6. Well, there is no 8 over here, but I know for sure that my final answer ends with an 8. But since I have a 6 over here, I know my answer is definitely ending in 8, but option D says that the answer is ending in 6. It's a different number. Here it is 8, here it is 6. I can conveniently presume that D is not my answer. It cannot be my correct answer. Let's move ahead. We still have 3 probable answers, out of which one is correct. Step B says multiply cross like this and like this. So I have 8 times 2 is 16, plus 5 times 1 is 5. 16 plus 5 is 21. I write 1, carry over 2. Let me look here. 18 is there in the end or not? Option A ends with 28, so it cannot be my answer. I need 18 in the end, so I cancel option A. Option B ends with 98. It cannot be my correct answer because I need 18 in the end. Option B is ruled out, and there is only one option left, option C. Here also 18, here also 18. I can conveniently take C as my correct answer. My final answer is 43318, which I get without working out all the steps, without continuing the multiplication problem. You see, I have only done 2 steps. I have not even done the remaining steps. The moment I got a unique option matching with the answer, I straight away ticked it as the correct answer. So here I am saving so much of time, energy and labor. That is why in such competitive exams like GMAT, SAT, CAT, GRE and many other exams where time is very critical, you must get the correct answer very fast. These techniques of Vedic math can be of very much help. When you use the traditional system, you don't get the final answer in the first line. You have to go through all the intermediary steps till you get the final answer. So this advantage is not available in the traditional system. It is only in Vedic math that you get the final answer in one line, and that is why we insist that these techniques are very, very powerful. Friends, we have seen 2-digit multiplication, we have seen 3-digit multiplication. Like this we can go on and on. We can multiply 4-digit numbers, 5, 6, 7, 8, 9. Any digit number by any digit number, you will get the answer in only one line. In my book Vedic Mathematics Made Easy, supplied to you along with the course, you can see designs of higher order numbers. Here we'll only take one example of 4 by 4 so that this concept becomes clear. Let us draw the design. For 4 by 4 multiplication, we use 7 steps: A, B, C, D, E, F, G. We have 4 dots above and 4 dots below. Let us see how to join them and form the design. So, step A goes like this: 1, step B has 2, step C has 3, step D we take all 4, again here we take 3, 2 and 1. After this example is over, I will teach you a technique by which you can learn how to join these dots in a particular pattern. First, let us have a look at an example. Suppose I have to multiply, say, 2, 3, 1, 2 by 1, 0, 1, 0. Step A says multiply these two numbers. So, 2 times 0 is 0. Step B says multiply like this and like this. We will add both the answers. 0 plus 2, 2. Step C says multiply this, this and this. So, we have 0 plus 1 plus 0, that is 1. Step D says take like this, this, this and this. Join the extremes and join the middle numbers. So, here we have 2, zeros are 0, 2 ones are 2, 0 plus 2 plus 3 plus 0. So, it is 5. Come to step E, join this, this and this. So, we have 2 plus 0 plus 1, that is 3. Step F says like this and like this. 3 ones are 3, 2 zeros are 0. 3 plus 0, 3. Last step says multiply these two numbers. 2 ones are 2. My final answer is 2, 3, 3, 5, 1, 2, 0, which you can see I got in only one line. Friends, whenever we learn a new technique, we think it's difficult, but no technique without practice can give you mastery. When you look at these dots and designs for the first time, you might get stunned or frightened, but worry not. They follow a scientific pattern or order which is very easy to find out. Next, I will teach you how you can form the steps that are used in this technique of multiplication with designs. Well, we follow a simple formula, the formula to get the number of steps, because unless you know how many steps are there, how can you join the dots? The formula is very simple. The formula says double minus 1. I repeat, double minus 1. Let me tell you how it works. When I multiply 2-digit numbers, now 2, double of 2 is 4 and 4 minus 1 is 3. That means I use 3 steps. When I multiply 3-digit numbers, double of 3 is 6 and 6 minus 1 is 5. So, I use 5 steps: A, B, C, D, E. Similarly, when I multiply 4-digit numbers, double of 4 is 8 and 8 minus 1 is 7. So, I use 7 steps. Suppose you have to multiply, say, a 10-digit number by a 10-digit number. Double of 10 is 20, 20 minus 1 is 19. So, we will be using 19 steps. This is just a theoretical case. We never multiply such long numbers. After finding out how many steps are required in the procedure, I will now teach you how you can join the dots and get the answer. Joining the dots is also very simple. Let us see how that works. When you multiply 2-digit numbers, begin from the right. So, I begin from the right, I take 1, go to my left, 2, again close and go to 1. So, the notation that is used here is 1, 2, 1. When I multiply 3-digit numbers, the notation will be, begin from the right, 1, go to your left, 2, go further to your left, 3, we have reached the maximum because there are 3 digits, close, 2, close once again, 1. So here you have 1, 2, 1. Here you have 1, 2, 3, 2, 1. Here also, let us see the notation. We begin from the extreme right. We take 1, go to the left, 2, go to the left, 3, go to the left, all 4, close, we have 3, 2, and 1. So here the notation is 1, 2, 1. Here the notation is 1, 2, 3, 2, 1. And here the notation is 1, 2, 3, 4, 3, 2, 1. Start from the right, keep on moving towards the left. After you have reached the maximum, you can close. For 2 by 2, it is 1, 2, 1. For 3 by 3, it is 1, 2, 3, 2, 1. 4 by 4, begin from the right, 1, 2, 3, 4, 3, 2, 1. Also you can see, first and last steps are mirror images, second and second last are mirror images, and there is a central figure. Look here. A and C are mirror images of each other. If you put A in front of the mirror, it will become C, and B is a central step. Here, A and E are mirror images of each other. B and D are mirror images of each other. If you put B in front of the mirror, it will look D. And C is a central figure. It has no mirror image. Here you can see A and G are mirror images of each other. They are opposite pairs. B and F, second and second last are mirror images. C and E, third and third last are mirror images. And D is a central figure. So these are the characteristics of the steps. Once you understand them, you can form steps on your own and multiply any number of any length and get the answer quickly. Now we will see 2 steps, one with unequal multiplication, and then I will teach you how this technique can be used in algebra. Friends, we have seen how to multiply 2-digit numbers, 3-digit numbers, 4-digit. But what if there are unequal digits? Suppose you have to multiply a 3-digit number by a 2-digit number. Then what do? Very simple. Suppose I have to multiply, say, 320 with 32. 3 digits on the top, 2 digits below. What I do is very simple. I put a 0 here and I make it 3 digit and my answer is done. Now I can use the technique of 3 by 3 and I can get the answer straight away. 0 times 2 is 0. It will become 4 plus 0, 4. Step C will be 6 plus 6, that is 12, plus 0, still 12. I write 2, carry over 1. Step D is 3 3s are 9, plus 0, 9, and 1, 10. So I write 0, carry over 1 again. Last step, 3 zeros are 0 and 1 carried over becomes 1. So my final answer is 1, 0, 2, 4, 0. Friends, we have seen how to use the crisscross multiplication when we do arithmetic. But the same can be used for algebra also, where you can multiply algebraic expressions and get the answer very fast. Let us have a look at a simple example. Suppose I have to multiply, say, a plus b by a plus 3b. First step says multiply these two numbers. B into 3b would give me 3b square. Then put a plus sign because both are plus. Step B says cross multiply like this and like this. So here we have a into 3b, that is 3ab, and a into b is ab. 3ab plus 1ab gives me 4ab. Plus last step says multiply these two numbers. A into a is a square. Our final answer is a square plus 4ab plus 3b square. Friends, let us see an advanced example in this. we have to multiply 5m square plus 5m plus 5 with the same number 5m square plus 5m plus 5. So first step says multiply these two numbers. We have 5 5s are 25. Second step will be like this and like this. So we'll have 25m plus 25m, that is 50m. Step C will be like this and like this. So it will be 25m square plus 25m square plus 25m square, that becomes 75m square. Step D will be like this and like this. 25m cube plus 25m cube, that is 50m cube. And the last step will be these two numbers. Multiply these two like this. 5m square plus 5m square is 25m4. My final answer is 25m4 plus 50m cube plus 75m square plus 50m plus 25. Friends, we will now see another very powerful technique of Vedic maths, which is called the base method. This technique can be used for multiplication and squaring of numbers very fast. When I say the base method, in the base method we use certain bases. These bases can be any numbers, but generally we use powers of 10. What are the powers of 10? We all know the powers of 10 includes numbers like 10, 100, 1000, 10,000, 1 lakh, 10 lakh and so on. Basically, when I say powers of 10, we mean numbers that begin with 1 and have zeros behind them. When we see examples, the powers of 10 will be clear. But first, let us see what are the 4 steps that are used in the base method. To find answers in the base method, we use the 4 steps that are written here. The first step says find the base and the difference. The second step says we have to find out the digits in the right part of the answer. The third step says we have to multiply the differences, and the fourth step says we have to find the cross answer. Now, when you look at the steps for the first time, they do not make any sense. But when we will see examples, we will see multiple examples at the same time. We will go through all the 4 steps and then the entire system will be clear. Using the base method, you can get answers of multiplication and squaring, and later on we will also see division in just one line. So friends, here I have taken 3 different examples. First, I have to multiply 96 by 94. Then 997 by 993. And the third example, I will multiply 9999 by 9999. Let us see how we can get the answer quickly in such cases. Now, as I said, the first step says find base and difference. So we'll find the base and we'll find the difference. I have to multiply 96 by 94. Ask yourself, to which power of 10 are both these numbers closer to? Are 96 and 94 closer to 10, 100, 1000, 10,000? Which number? We see both these numbers are closer to 100. So our base in this case is 100. Here 997 and 993. Ask yourself, are both the numbers closer to 10, 100, 1000, 10,000? Suppose you went to the shop and you bought materials worth $997 or 997 pounds. How much would you pay? Would you pay $10 or pounds, $100 or pounds, $1,000 or pounds? Well, you would pay anything that is in 1000 units of currency. We see both the numbers are closer to 1000. So our base in this case will become 1000. And here I know the numbers are closer to 10,000. So the base in this case will become, we have found the base, now let us find the difference. 100 minus 96 is 4 and 100 minus 94 is 6. So my difference is 4 and 6. Here 1000 minus 997 gives me 3 and 1000 minus 993 gives me 7. We have found the base, we have found the difference. And here 10,000 minus 9999 is 1. Again 10,000 minus 9999 is 1. We have found the base, we have found the differences. So I have found the base and I have found the difference. Second step says I have to find out the digits in the right part. Answer will be obtained in two parts, left and right. I have to find out how many digits will be there in the right part. How do I find out? It's very simple. There are 2 zeros in 100, so right part will be a 2-digit answer. Second step is over. How many zeros are there in the base? There are 3 zeros over here, so right part will have a 3-digit answer. How many zeros are there in the base? There are 4 zeros in 10,000, so right part will be a 4-digit answer. Second step is also very easy. Howsoever many zeros are here, that many digits you put. 100 there are 2 zeros, so right part will be a 2-digit answer. In 1000 there are 3 zeros, so right part will be a 3-digit answer. In 10,000 there are 4 zeros, so right part will be a 4-digit answer. Step B is also over. Step C says multiply the differences. So let us multiply. So minus 4 multiplied by minus 6. We know minus minus becomes plus. So minus 4 into minus 6 will give me 24, which I write in the right part. Similarly, minus 3 into minus 7, minus minus becomes plus. Minus 3 into minus 7 gives me plus 21. But I need a 3-digit answer. How do I convert 21, which is a 2-digit number, into a 3-digit number? Simple. Write it as it's 0, 21. And third step says minus 1 into minus 1 is plus 1. But I need a 4-digit answer. So instead of writing 1, I write 0, 0, 0, 1. Step C is also over. And the last step says find the cross answer. So when I say cross, we can take like this also, or we can take like this also. This way is also okay, this way is also okay. In both the cases, we will get the same answer. Let us see how that is done. Here, so 96 minus 6 will give me 90, or I can take cross like this, 94 minus 4 will give me 90. My answer is 9024. That means, friends, when you multiply 96 times 94, your answer is 9024. Here, when I do cross, 997 minus 7 is 990. Or I can take cross like this, 993 minus 3 is 990. Whether I take this way or this way, my answer will be same. So here my answer is 990021. When 997 is multiplied by 993, I get my answer in only one line, 990021. And here also we will take the cross answer, 9999 minus 1. We can take like this also, we can take like this also. So my answer is 9999 minus 1, which is 9998. My final answer is 99980001. So you see, we got all the three answers in just one line. I will quickly revise this technique with you with all the answers already given to us. We have three independent questions. The first question says multiply 96 by 94. Second question says multiply 997 and 993. And third question says multiply 9999 by 9999. First step was to find the base and the difference. Here both 96 and 94 are closer to 100, So we take 100 as the base. Here both 997 and 993 were closer to 1000, so my base becomes 1000. And 9999, here also 9999 is closer to 10,000. Both the numbers are closer to 10,000. So we found the bases, and next we were to find the differences. 100 minus 96 gave us 4, 100 minus 94 gave us 6. 1000 minus 997 is 3, and 1000 minus 993 is 7. I have found the base and the difference. And 10,000 minus 9999 is 1. Again 10,000 minus 9999 is 1. So I have found the base and I have found the difference. Next we had to find out digits in the right part. That was very simple. I said howsoever many digits are here, that many digits in the right part. So there are 2 zeros in 100, 2 digits in the right part. There are 3 zeros over here, so right part has to be a 3-digit answer. And there are 4 zeros here, therefore I put 4 digits in the right part. Howsoever many number of zeros, that's however many digits will come here. 2, 2, 3, 3, 4, 4. The third step said multiply the differences. So I multiplied the differences. Minus 4 into minus 6 gave me 24 in the 2 digits. Minus 3 into minus 7 gives me plus 21, but I needed a 3-digit answer. So instead of writing 21, I wrote 0, 2, 1. And in the third example, minus 1 into minus 1 gives us 1. But I needed a 4-digit answer, so I wrote 0, 0, 0, 1. I multiplied the differences. And the last step said find the cross answer. So I took 96 minus 6 is 90, or I could have taken 94 minus 4 is 90. This also gave me 90, this also gave me 90. Both the cases will always give you the same answer. Your final answer is 9024. In the second case, 997 minus 7 gives me 990, or as I said, I could have taken like this, 993 minus 3 gives me 990. So when I multiply 997 by 993, final answer is 990021. And the last step says 9999 minus 1 will give me 9998. My answer is 99980001. Thus friends, you see how the base method helps you get answers of such complicated questions in just one line. Friends, let us quickly have a look at an example. Suppose I have to multiply, say, 9980 by 9970. Now, both the numbers are closer to 10,000. So my base in this case will be 10,000. The difference between these two numbers is 20, and the difference between these two numbers is 30. So we have found the base and we have found the difference. Let me get the answers further. I have to check how many digits will be there in the right part. In 10,000 there are 4 zeros, so right hand part will be a 4-digit answer. Third, I have to multiply the differences. Minus 20 into minus 30 gives me plus 600, but I need a 4-digit answer. So instead of writing 600, I write 0600. And the last step says find the cross answer. So I go cross. 9980 minus 30 would give me 9950. Alternatively, I can take 9970 minus 20, 9950. My final answer is 99500,600. Thus, you see with Vedic Maths, we can get the answer very fast. Friends, we saw how to multiply numbers below the base. Next, let us see how to multiply numbers above the base. We will take two different examples. Suppose I have to multiply, say, 102 with 103, or I have to multiply 1020 with 1010. Let us see how we can get the answer. Now, both these numbers are closer to 100. So our base in this case will become 100. Here we see both the numbers closer to 10, 100, 1000. We see both the numbers are closer to 1000. So our base in this case is 1000. We have found the bases. Next, let us find the difference. 102 is 2 more than 100. So it is more, our difference will be plus 2. And 103 is 3 more than 100. So our difference in this case will be plus 3. So we have found the base and we have found the differences. So 1020 is 20 more than 1000. So difference in this case will be plus 20. And 1010 is 10 more than 1000. So difference in this case will be plus 10. So we have found the bases and we have found the differences. Next, we have to find the number of digits in the right part. Here we see 100 as 2 zeros, so right part will be a 2-digit answer. And here we see 3 zeros in 1000, so right part will be a 3-digit answer. Third step says multiply the differences. So 2 times 3 is 6, but I need a 2-digit answer, so I write 0, 6. And 20 into 10 is 200, so I write here 200. And my final step says find the cross answer. So we see 102 plus 3, that will give me 105, or I can take 103 plus 2. My answer will be 105. My final answer is 10506. Here again, either I can take like this or I can take like this. My answer is 1020 plus 10, 1030, or I can take 1010 plus 20, 1030. My final answer is 1030200. So friends, when we multiply 102 with 103, our answer is 10506, and when we multiply 1020 with 1010, our answer is 1030200. Friends, at times we might have digits in the right part exceeding. Let us see how to do that. Suppose I have to multiply, say, 950 with 950. Or say, let us take a very simple example. I have to multiply 13 times 14. Let us see how we get the answer. We see both these numbers are closer to 1000. So the base is 1000. Both these numbers are closer to 10. So the base is 10. Here the difference between these two numbers is minus 50. Difference between these two numbers is minus 50. Here difference between 10 and 13 is plus 3, because 13 is more than 10. If the number is more than the base, we have plus, and if the number is less than the base, we have minus. 14 is more than 10 by 4 units, so we have plus 4. We have found the base and we have found the differences. Next, howsoever many zeros, that many digits in the right part. 3 zeros in 1000, right hand side will be a 3-digit answer. There is 1 zero in 10, so there will be 1 digit in the right part. Third step says multiply the differences. 50 times 50 is 2500. How do we do it? 5 times 5 is 25 and put 2 zeros behind it. So 50 times 50 is 2500. Now 2500 is a 4-digit number, but I just have 3 spaces over here. What do we do? Very simple. Start writing the number. I have to write 2500. So I write 0, 0, 5 and I carry over 2 as a carryover. Here plus 3 into plus 4 is 12. 12 is a 2-digit answer, but I have space for only 1 digit. So I write 2 carry over 1. So here also we have finished step C. Here also we have finished step C. Step D says find the cross answer. So 950 minus 50, I get 900. And here I go, I can take 13 plus 4 also, or I can take 14 plus 3 also. My answer would be 13 plus 4 is 17. So let us get our final answers. My final answer will be 9 comes down as 9, 0 comes down as 0, 0 plus 2 is 2, 5 comes down as 5, 0 comes here as 0, 0 comes here as 0. So my final answer is 902500. And in this case my final answer would be 1 comes down as 1, 7 plus 1 is 8, 2 written down is 2. So my final answer is 182. There is nothing exceptional that we have done. It's just that when you have more digits, you carry over. That's it. The rest of the technique remains the same. Friends, next let us see how to multiply numbers with different bases. Here we will see when numbers are having bases 10, one number is having bases 100, how to multiply. If one number is having base 10,000, one number is having bases 1000. So if there are different bases, also you can multiply them. Let us see a technique of this type. Suppose friends, I have been given a question. I have to multiply 85 times 995. Now you see 85 is closer to 100 and 995 is closer to 1000. So both the numbers are having different bases. What we do is we introduce some sort of uniformity. What I do is I multiply 85 by 10, so now it becomes 850 multiplied by 995. Now we see both the numbers are closer to 1000. Let us do the example and get the answer. But since I have multiplied by 10, I will divide the answer by 10 again to get the original answer. Let us see how this is done. I have to multiply 850 with 995. Now both 850 and 995 are closer to 1000. So our base in this case will be 1000. Next, difference here is 150 and the difference here is 5. Next, we see 3 zeros in 1000, so right part will have 3 digits. When we multiply 150 by 5, minus minus will become plus, as we know that. 150 times 5 is 750. And then I take the cross, 850 minus 5 becomes 845. So my answer is 845750. But as I said, since we have multiplied by 10, we will now have to divide by 10 to get the original answer of 85 multiplied by 995. So I will now divide by 10. Divide by 10 is very easy. I just cut this 0. Now my answer becomes 84575. So when I multiply 85 times 995, the answer is 84575. Friends, in the base method, there are various permutations and combinations where you can multiply numbers below the base, multiply numbers above the base, multiply when one number is below the base, one is above the base, multiply numbers with different bases. All these examples you will find in my book Vedic Mathematics Made Easy. In the DVD content, we will be selecting certain examples of different types and I will be teaching them to you so you can understand better. For more reference, you can refer my books applied to you in this course. Friends, we now come to the last example of a study on base method, where we will see how to multiply when one number is below the base and one number is above the base. Let us see how that is done. Suppose I have to multiply, say, 95 by 105. Both these numbers are closer to 100, so the base in this case will be 100. But the difference here is minus 5 because 95 is 5 less than 100 and the difference here is plus 5 because 105 is 5 more than 100. So we have 1 minus 1 plus. Very simple how to deal. All the remaining steps are the same. 2 zeros in 100, so right hand side will be a 2-digit answer. So friends, we have to multiply minus 5 by plus 5. We know minus into plus will give us ultimate answer as minus. So minus 5 into plus 5 is minus 25. And then we take the cross answer. Either we can take 95 plus 5 as 100, or we can take 105 minus 5 as 100. Now our answer at this point of time is 100 and negative 25. Either case our answer will be the same. Here my answer is 100 and negative 25. Now negative 25 is not permitted in between. So what you do is very simple. Take the left hand side, multiply it by the base, and then subtract the right hand side. So what we do is we take the left hand part, multiply it by the base, then subtract the right hand part. Let us see how that is done. Here we have 100, we multiply it by 100, then remove 25. So it will be 100 into 100 minus 25. 100 multiplied by 100 will give me 10,000 minus 25. My answer is 9,975. Thus, when you multiply 95 by 105, your answer is 9975. Friends, we will next study the technique of how to find cube roots very fast. First, let us revise what is cube roots. When we multiply a number by itself, we get a square of that number. If I multiply 4 times 4, I get 16. 16 is the square, 4 is the square root. When I multiply 7 by 7, I get 49. 49 is the square, 7 is the square root. So when I multiply a number by itself, I get the square of that number. But friends, when I multiply a number by itself and again by itself, I get the cube of that number. If I multiply 2 by 2, I get 4, and if I multiply 4 by 2, I get 8. So 8 is the cube of 2, and 2 is the cube root of 8. When I multiply 3 by 3, I get 9, and when I multiply 9 by 3, I get 27. 27 is the cube of 3, and 3 is the cube root of 27. Now, it is very easy to find out cube roots of such small numbers like 8, 27, 64. But what if you have complicated numbers like say 1,75,616 or say 4,05,244? Well, with the help of Vedic maths, you can find cube roots of such numbers in 1 or 2 seconds itself. This technique is one of the hallmark techniques of Vedic maths. Let us have a look at how this technique works. So, let us find the cube roots of all the numbers. Before that, we need to take a standard key where I will take numbers from 1 to 10 and write the cube of each number below it. Let us see how that is done. First, the cube of 1 is 1, cube of 2 is 8, 3, 27, 4, 64, 5, 125, cube of 6 is 216, cube of 7 is 343, cube of 8 is 512, cube of 9 is 729, and cube of 10 is 1000. You need not memorize this key, but I have just given them numbers as a reference. So, I have numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and I have the cubes of all the 10 numbers with me. Now friends, if you observe, there is a unique relationship between the last digit of the cube and the cube root. Let me show you what that is. We observe that if the cube ends in 1, cube root ends in 1. If the cube 8, root ends in 2. Cube ends in 3. Cube ends in 4, root ends in 4. Cube ends in 5, root ends in 5. Cube ends in 6, root ends in 6. Cube ends in 3, root ends in 7. Cube ends in 2, root ends in 8. Cube ends in 9, root ends in 9. And cube ends in 0, the cube root also ends in 0. So friends, from the last digit of the cube, we can find last digit of the cube root. Cube ends in 6, then root will end in 6. Cube ends in 3, root will end in 7. Let us revise. If the cube for 1, it is 1. Let us take the same numbers. 4 is 4, 5 is 5, 6 is 6, 9 is 9, 0 is 0. All are same. 1 is 1, 4 is 4, 5 is 5, 6 is 6, 9 is 9, 0 is 0. And we have opposite pairs. If the cube ends in 3, then the cube root will end in 7. And if the cube ends in 7, the cube root will end in 3. If the cube ends in 2, the cube root will end in 8. And if the cube ends in 8, the root will end in 2. So friends, let us find the cube root of 2 to 3 difficult numbers. First, I want to find the cube root of 2,62,144, or in other words, 262,144. Next, I want to find the cube root of 12,167. And last, I want to find the cube root of 1,17,649, or in other words, 117,649. Now the rule says whenever a number is given to you, you put a slash and divide the number in such a way that there are 3 digits in the right hand. So here I will put a slash between 2 and 1 such there are 3 digits in the right hand. In the second example, I will put a slash between 2 and 1 such that there are 3 digits 1, 6, 7 in the right hand side. And in the third example, I will put a slash between, I divide the number from 7 and 6 such that there are 3 digits 6, 4 and 9 right hand. Let us see how we get the answer. Cube ends in 4, and we have seen that if the cube ends in 4, cube root ends in 4. So I am putting a dash, but it certainly ends with a 4. Here friends, the cube ends in 7. We see if the cube ends in 7, the cube root ends in 3. I don't know what it begins with, but it ends with a 3. Here the number ends in 9, cube root ends in 9. Let's check. If the cube ends in 9, the cube root also ends in 9. So the cube root will also end in 9. We don't know what it begins with, but ends with a 9. We have found 3 half answers with us. Let us get the complete answers now. How do we get the complete answers? For the complete answers, we look at the part to the left of the slash. What is to the left of the slash? The number to the left of the slash here is 262. Ask yourself, let us see between which 2 numbers 262 comes. 262 does not come between 729 and 1000. Neither does it come between 512 and 729. We know 262 is bigger than 216 and smaller than 343. 262 therefore comes between 216 and 343. In other words, 262 is between 6 and 7. Now ask yourself, out of 6 and 7, which is the smaller number? We know out of 6 and 7, 6 is the smaller number. So I take 6 and I fill it in the blank over here. So my answer is 64 is the cube root of 262,144. Similarly friends, in the second question, the number to the left of the slash here is 12. Ask yourself, where will 12 come in the number line? So ask yourself, is 12 between 1 and 8? No, it doesn't come between 1 and 8. No. Does 12 come between 8 and 27? Yes, because 12 is bigger than 8 and smaller than 27. That means it is between 2 and 3. As I said, out of 2 and 3, we will take the smaller number and write down. Out of 2 and 3, smaller number is 2. So I take 2 and I write 2 in the blank. So I know 23 is the cube root of 12,167. My answer is 23. Similarly friends, check where will this left part 117. Ask yourself, where will 117 come in the number line? We know 117 is between 64 and 125. 117 is bigger than 64 and smaller than 125. Therefore, 117 is between 4 and 5. Ask yourself, out of 4 and 5, which is the smaller number? We know out of 4 and 5, the smaller number is 4. So I take 4 and fill it in the blank. So my answer in this case will be 4 and 9, 49. 49 is the cube root of 117,649. So my answer is 49. The cube root of 117,649 is 49. Thus you see, using Vedic math, we can get answers of such complicated numbers just by observing certain relationship between the digits. Next we will see one or two more examples, after which this technique will be clear. So let us find the cube root of say 4, 0, 5, 2, 2, 4. I have to put a slash in such a manner that there are 3 digits in the right hand side. So I divide this number over here, I have 3 digits in the right hand side. Now the cube ends in 4, that means the cube root will also end in 4. For 4 it is 4. So I don't know what it begins with, but certainly ends with 4. And next I check where will 405 come in the number line. So now the part to the left of the slash is 405. 405 is bigger than 343 and smaller than 512. In other words, 405 is between 343 and 512, or between 7 and 8. We know out of 7 and 8 the smaller number is 7. So I take 7 from here and put it in the slash over here. My answer is 74. The cube root of 405224 is 74. Suppose I want to find out the cube root of say 287496. It's a 6-digit number. I will put a slash in such a manner that there are 3 digits in the right hand side. So I put a slash over here. Now the number ends in 6, and we know if the cube ends in 6, cube root ends in 6. So here our answer, I don't know what it begins with, but ends with a 6. And next 287, find out where does it come in the number line. We know 287 is between 216 and 343. 287 is bigger than 216, smaller than 343. That means 287 lies between 6 and 7. Out of 6 and 7, the smaller number is 6. So I take 6 from here and write down here. So the cube root of 287496 is 66. Thus you see, using Vedic math, you can get the answer of any cube just by looking at the number. But remember, this technique can only be used for perfect cube roots, not for imperfect cube roots. And the traditional method, which otherwise requires 15 to 20 steps to do this technique, with the help of Vedic math, you can get the answer in just 1 or 2 steps. Friends, we just saw how to do cube roots very fast. Next, we will see how to do square roots very fast. When I multiply 2 by 2, I get 4. 4 is the square, 2 is the square root. When I multiply 8 by 8, I get 64. 64 is the square, 8 is the square root. Next, let us see how to find square roots of complicated numbers very fast. So, like we did in cube roots, in square roots also, first we will take numbers from 1 to 10 and we will write the square of each number below it. So, square of 1 is 1, 2 is 4, 3 is 9, 4 is 16, 5 is 25, 6 is 36, 7 is 49, 8 is 64, 9 is 81 and 10 is 100. So, we have taken numbers from 1 to 10 and we have written the square of each number below it. So, like we observed in cube roots, again we are going to observe certain relationship between the digits. Let us see what is the relationship between the digits. We observe, friends, that if the square ends in 1, the square root ends in 1, or if the square ends in 1, square root ends in 9. 1 is equal to 1 or 9. If the square ends in 4, square root ends in 2, or if the square ends in 4, square root ends in 8. So, if the square ends in 4 equals 2 or 8. If the square ends in 9, square root will end in 3, or if the square ends in 9, square root will end in 7. 9 equals 3 or 7. Square ends in 6, square root will end in 4, or if the square ends in 6, square root will end in 6. 6 equals 4 or 6. If the square ends in 5, square root will end in 5. And if square ends in 0, the square root will end in 0. 5 equals 5, 0 equals 0. Let us revise once again. For 1, it is 1 or 9. For 1, it is 1 or 1 can be 9. 4 is 2 or 8. Let us check. 4 is 2, 4 is 8. 9 is 3 or 7. 9 is 3, 9 is 7. 6 is 4 or 6. 6 is 4, 6 is 6. 5 is 5, 0 is 0. 5 is 5, 0 is 0. An easy way to remember this entire key is to note that both these numbers always total up to 10. 1 plus 9 is 10, 2 plus 8 is 10, 3 plus 7 is 10, 4 plus 6 is 10. These are single numbers. So friends, on the basis of observing the last digit of the square, we can find the last digit of the square root. Square ends in 1, root will end in 1 or 9. Square ends in 9, root will end in 3 or 7. Next, let us see a few examples where this technique can be used. Friends, what I have done here is, I have taken numbers in the multiples of 10, like 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, and I have written the squares of each number below that. Square of 10 is 100, 20, 400, 30, 900, 40, 1600, like that. 100 will be 10,000. We already saw the previous key, we have just added zeros to it. If the square of 4 is 16, then 40 will be 1600. If the square of 5 is 25, then 50 will be 2500. If the square of 6 is 36, then 60 will be 3600. You need not copy or memorize this key. This is just for reference. Suppose friends, I want to find the square root of the number 3721. Ask yourself, is 3721 closer to the smaller number 3600, or is 3721 closer to the bigger number 4900? We also know that the number ends in 1, and we just saw in the key that if the number ends in 1, the square root ends in 1 or 9. That means the answer of this is also between 1 and 9. So what do we observe? First, we know that our answer is between 60 and 70. That means our possibilities are 61, 62, 63, 64, 65, 66, 67, 68, 69. So our possibilities are 61, 62, 63, 64, 65, 66, 67, 68, 69. These are our possibilities if it is between 60 and 70. But the second step says that if the number ends in 1, then the square root will end in 1 or 9. Let us check which of these numbers end with 1 or 9. Only two numbers. Either our answer is 61 or our answer is 69. End with 1 or 9. That means either our answer is 61 or our answer is 69. You need not write all these numbers. They are just because I am explaining it to you for the first time. So either our answer is 61 or our answer is 69. Next, you must find out which amongst these two is the correct answer. How do you do that? Ask yourself, is this number 3721 closer to the smaller number 3600 or bigger number 4900? If 3721 is closer to the smaller number, we will take smaller as the answer. And if 3721 is closer to the bigger number, we will take bigger as the answer. In this case, friends, we see 3721 is closer to 3600, the smaller number. That means out of these two, the smaller number 61 is our answer. Had it been closer to the bigger number, we would have taken 69 as the answer. So here, friends, we know the square root of 3721 is 61. Next, friends, let us find the square root of the number 9801. We know, friends, that 9801 is bigger than 8100 and smaller than 10,000. That means our answer is between 90 and 100. So we go ahead and check all the numbers between 90 and 100. Now, because the number ends in 1, as we have seen, the square root will end in 1 or 9. Now we know that the answer is between 90 and 100, and also we know that it ends in 1 or 9. Between 90 and 100, we have numbers like 91, 92, 93, 94, 95, 96, 97, 98, 99. Again, we are interested in only those numbers ending in 1 or 9. So our possibilities are either 91 or 99. Let us see which out of these two is our correct answer. Ask yourself, is 9801 closer to the smaller number or the bigger number? If it is closer to the smaller number, we take smaller as the answer. If it is closer to the bigger number, 10,000, we take bigger number as the answer. In this case, friends, we see 9801 is closer to the bigger number 10,000. That means out of 91 and 99, the bigger number 99 is our answer. So 99 is the square root of 9801. Friends,